Hello everyone. So my name is Lakshay. I welcome you all to the discussion of AIATS plus phase 2. And now in this paper, in this whole series, we are dealing with a mock test along not only the questions we are dealing, along with it we are dealing with the conceptual part. Okay, so let us start from the very first question of the topics we have decided. Okay, so let us start. Okay. In the very first question, we have a question number 66. In this question, we all know that we will be given a substrate and we have to react it with the copper. It means this is simply alcohol chemical properties. So let us discuss some of the basic criteria, then we will discuss the question back. Okay. So let us go to the conceptual. Okay. So just a second. Okay, so in this discussion, the first and the foremost point is that we should know that how the reaction proceed. Let us say you have an alcohol. It means when you have to convert the alcohol to the aldehyde or ketones, it means what you are doing. It means aldehyde or ketones, it means you are doing oxidation. So please be clear. When you convert the alcohol to aldehyde or ketones, it means you are oxidating it. Next, after this, when you are converting aldehyde or ketones to carboxylic acid, carboxylic acids, it means again you are oxidating it. And if it is feasible to move back, it means the whole step is reduction. This is the first and the foremost thing you should be aware about it. Okay. So, but we have assumed that, or we have been clearly defined that to control this reaction and to hold up to this part, it is very difficult part, because mostly the oxidating reagents we have are mostly strong. So the alcohol gets directly converted to the carboxylic acid. So we can say that the conversion of alcohol to aldehyde or ketones, it is not an easy method. It is not an easy way to deal with. Okay, we can say that this is partial oxidation. Partial oxidation. I hope the whole scheme about the conversion of alcohol to aldehyde ketones then to carboxylic acid is clear to you all. Okay, so let us discuss something more in detail so that we can carry out the reaction selectively to the aldehyde or ketones. Okay, there are some reagents who can do it. Okay, let us discuss the same. Okay, on moving to the next part, if we are dealing with, let us say we have taken the alcohol and you are reacting it with strong, let us say you have taken KMnO4. Or acidified KMnO4 is very strong oxidating reagent. So what can it do? It will oxidize it and will convert to acid. It means the aldehyde ketones will not be the major product. It will directly convert to the carboxylic acid. It means it is very strong. So we have to reduce the oxidating power of the reagents we have to. Let us discuss the same. Okay, if you have to convert this to this, it is a major task to deal with. So there are certain reagents which can do these kind of reactions, or we can say that partial oxidation. Okay, so let us discuss which are this. We can say that the first reagent you can take is chromium trioxide, or we can say that CrO3. This reagent can easily convert this alcohol to aldehyde. Or we can say that, what are others? The second one you can take is copper and the temperature is mentioned at 573 Kelvin. this can also selectively oxidize the alcohol to aldehyde or ketones. Okay, so let us discuss any one of the same, and the other reaction follows the same order. Okay, so let us discuss about the copper in the presence of 573 Kelvin at the temperature. Okay, so if you have, let us say, an alcohol, and we can say that it is primary alcohol, and you are reacting with copper at 573 Kelvin. So what will be the product? And as we have already discussed, that copper at 573 Kelvin will oxidize to only aldehyde or ketones. It will not convert to the carboxylic acid, and you will get R C double bond O H. This will be the major product in this part. Okay, if you have taken a secondary alcohol, let us say you have taken R and OH, and you are reacting with same copper at 573 Kelvin, you will again get aldehyde or ketone depending upon the substrate. As you have taken the secondary, it means the ketone will be the major product, R and R. This will be the major product. Okay, because it has a presence of this hydrogen. These can eliminate. Or we can say that this is the major reactions dealing with. I hope this is clear. So shall we move to the tertiary alcohol, the most important part? Shall we? Okay, let us move to the tertiary one. Let us say we have taken. If you have R, OH, we can clearly say this is 3-degree alcohol. If I took an independent substrate, let us say we have taken this, and you are reacting with copper at 573 Kelvin. So what will be the major product? Do it transform to the carboxylic acid or not? It will not. Will it convert to the aldehyde or ketones? Obviously not, because this position is not having any kind of hydrogen to eliminate it. I hope this is clear, but in this part the reaction will move. And what will you get? You will get an alkene. The one hydrogen will move from it, and the removal of these water will take place from here. And you will get alkene as a major product. This is the major product, and this is the most important part that you guys have lagged behind. Okay, so this is the main crux of this reaction. Every reaction will move in that manner at the primary, and the secondary will get you the aldehyde or ketones as a selectively major product, and in case of tertiary alcohol, you will get an alkenes. Okay, shall us move to the question part? Okay, let us discuss. We have a question this. It means we have two-methyl propane 2-ol. So what is the structure of this? Propane 2-ol means OH is there and CH3 is also there. We can provide the exact structure of this. It means we can clearly say it is of 3-degree alcohol. And on reaction with copper at 573 Kelvin, you will get an alkene. This is the major product of this reaction. I hope this is clear to you all. Is it? Okay, so the product is option number 1. Shall us move to the next conceptual question? Good afternoon, everyone. Good afternoon. Okay, let us move to the next question and discuss what the next question is majorly dealing with. Okay, we have a question number 68. In this reaction, what is it? This is the conversion of toluene to benzaldehyde. Toluene to benzaldehyde. This reaction is benzene conversion of toluene to benzaldehyde. So what is the name of this reaction? We have already studied it. What is it? This is simply a AIATS reaction. Let us discuss the whole reactions we are dealing. Okay. So let us discuss the first AIATS reaction. Okay. In AIATS reaction, what is it? The first substrate you are dealing is toluene. And on reaction with CrO2Cl2, what will you get? You will get an intermediate, and this intermediate is very, very special intermediate, because this intermediate can be asked in your examination. What will you get? You will get CHOCrOHCl2. This is the intermediate you will get in the part of this reaction. So what is the best way to represent? We have to represent in the box. So this is the intermediate we are getting. This is intermediate. And on reaction with water, are these bonds polar in nature? Yes, obviously they are polar. So what will you have to react? The water will hydrolyze this polar bond, and you will get CH, OH and OH, because these two bonds will be broken on the side of oxygen, and you will get OH and OH. And we all know that at one carbon there is a very least tendency for the two OH to get stabilized over there. It means there will be the release of water molecule. Yes, obviously yes. And there will be the release of water molecule, and you will get a product like this. This is benzaldehyde. This is the AIATS reaction. I hope this reaction is clear to you all. Shall us discuss some more name reactions so that your revision will be takes place, or if you guys have any kind of doubts in the name reaction, all doubts will be cleared simultaneously. So let us discuss what other reactions we're dealing. It means obviously the reaction is option number 1. This is an AIATS reaction. Okay. Let us discuss some other name reactions so that your concepts will be revised. Okay. So let us discuss the HVZ reaction. What is it? The second reaction is HVZ. So what is the full form of HVZ reactions? Can anyone? What is the full form of HVZ reactions? This is simply Hell-Volhard-Zelinsky reaction. This is Hell-Volhard-Zelinsky reaction. In this reaction, the first and foremost thing you should have as a substrate is the presence of alpha hydrogen carboxylic acid. It means you will be having a carboxylic acid having the carbon present at alpha position having hydrogens. It means you must have the hydrogen over here. It can be 1 or it can be 2. It's up to the reaction part. Okay, and what you are reacting with, and you will react with in the presence of red phosphorus in the presence of any halogen. Let us say you have taken a chlorine. This is the first, and the second part you will be adding water. So what is the major product you will get? You will simply get RCOOH, and at the alpha position the substitution takes place. And what if you look at in place of hydrogen, you will be getting an halogen. This is the chlorine. We can say that this is alpha halo carboxylic acid. This is alpha halo carboxylic acid. This is very important substrate for the formation of amino acids. Okay, this is the most important substrate for the formation of amino acids. You have discussed in the biomolecules. Okay, what is the difference between it? If you are reacting with ammonia, this chlorine will remove and the nitrogen NH2 will be here. And this, if you are replacing the R group with different alkyl groups of the substrates, you will be getting different types of amino acids, whether they are essential or they are not non-essentials. Is it? Yes, this is very important for the preparation of act as a substrate for amino acid. Okay, so let us go to the next name reaction. And what is it? The third one is Gutterman-Koch. Gutterman-Koch reaction. This reaction is majorly dealing with the preparation of aldehyde. And what will you get? The substrate of this is, you will be having an benzene, and you are reacting with CO in the presence of HCl in the presence of anhydrous Lewis acid. We can say that AlCl3. You will get a benzaldehyde. As a major product. This is the product formation in this reaction. Okay? Is it clear? Yes. That's good. So the fourth and the last reaction of the name reaction of that question will be, the fourth one is Finkelstein reaction. Finkelstein reaction. I hope this reaction have been already discussed by the Mukesh sir in your previous session, where in the haloalkanes and haloarenes chapter. So let us discuss something more in detail so that you guys will be left no doubts in this. You will be having any alkyl group you have, any halogens. Let us take an halogen over here, and you are reacting with NaI in the presence of dry ether. What will you get? This halogen will be replaced by this, and you will get R I plus an NaX could be the product. So this is the preparation of alkyl iodide over here. Is it clear? Exactly. This is the preparation of alkyl fluoride. No, this is not the preparation of alkyl fluoride. This is the preparation of alkyl iodides. Okay, let us discuss some more questions. Yes. Now you are absolutely correct. This is the preparation of alkyl iodide. Yes. Now we have a question number 69. What is it? The compound which cannot be synthesized by the Gabriel thalamide synthesis. I hope these kind of reaction or this kind of reaction we have already discussed in the previous class. And the question will be repeated. because this is a very, very important conceptual part of your amines chapter. So shall I discuss them again? Let us discuss them briefly so that your concept will be revised again. So we have a Gabriel phthalimide. Okay, what is it? In this reaction you have phthalic acid. We will discuss in the very brief manner so that everything will be clear. We have a phthalic acid. What is it? C double bond O, OH. C double bond O, OH. When you are reacting with ammonia and heat it, you will be having, and we are not dealing with the kinetical part. This reaction is a reversible reaction. So we can say that C double bond O and H. C double bond O, this could be the formed, and when you are reacting with base KOH, this will form a negative charge over here. This will form a negative charge again. So it is N minus K plus C double bond O. Now the negative charge will be formed, and when you are reacting with, and you have to react with alkyl halide, so this negative charge will attack at the anti-bonding orbital of Rx, or we can say that Cx, and you will be having C double bond O and R, C double bond O, and this will be formed over here. Okay, and now after this you will be having C double bond O and R, C double bond O and R, and after there will be the presence of base again. So on reaction with base, or we can say that hydrolysis H2O, you will be getting R and H2, because the hydrolysis will take place. The water will hydrolyze this polar bond, and you will be getting this R and H2. Is it clear? Okay. But the major constraint over there here is, as we are reacting this negative charge, we can say that the nucleophile will attack at the electrophilic center of the CX bond, and you will be getting the product. This is simply a SN2 reaction. So what will be the case if you are having aniline preparation? It means you have to take alkyl halide. So whether these species N minus C double bond O, K plus, will it attack over here via SN2 mechanism? Obviously not. It will not react over this. If it is not reacting with it, it means you will be not having these kind of products like aniline. And why will it not be react over this haloarenes? It's just because the lone pair of halogen is in conjugation with the pi density of benzene ring, making a partial double bond character at the carbon halogen, making a very difficult to live. Obviously correct. So it means there will be no steric hindrance over here. There will be the formation of partial double bonds. Let us say you are having a single bond, it will be easy to break, and if you are having the two bonds, it means it is very difficult to break these bonds. It means SN2 will be no case over here. I hope this is clear. It means aniline cannot be prepared by a method called Gabriel phthalimide synthesis. Exactly, it is very difficult to break this bond. It means we can say that this cannot be synthesized by Gabriel phthalimide. This can be prepared, this can be. And the correct answer of this is this, obviously. And the Gabriel phthalimide synthesis is basically used for the preparation of primary amines. Perfectly clear. I hope this concept is clear to you all. Is it? Okay, let us move to the next question where we will be discussing the next concept. Okay, we have a question number 73. Okay, now a very important reaction of Kolbe synthesis, Kolbe reaction of phenols, a very, very important part. Let us discuss the Kolbe reaction of phenol in very detail and with the explanation of the mechanistical approach, so that every point will be crystal clear to you all. So let us discuss the Kolbe reaction. We can say that this is the chemical property of phenols. Obviously, perfectly correct. It means in Kolbe reaction, if this is a chemical property of phenol, it means the substrate is obviously a phenol. It means you have taken the OH here. Yes, Poonam, absolutely correct. The product is salicylic acid. We will discuss in detail the mechanistical approach, so that if anyone will ask you what is the intermediate over here, or what will be the process to deal with, which is an electrophile, or nucleophile, what will be there. So we will be discussing everything in detail. Okay, you are reacting with base. You are having, if this is a base, it will abstract a proton from substrate, and this OH will be very much acidic, So this negative will abstract a proton and will form O minus Na plus. We can say that this is a sodium phenoxide, absolutely correct. After this, you are reacting with CO2. And now, this is simply a electrophile-nucleophile reaction. This is a nucleophile. This is an electrophile. And how CO2 will act as an electrophile? Can anyone give me the answer? How CO2 will be acting as an electrophile? Because of the presence of two double bonds. So it means that there will be the deficiency due to the minus I effects of oxygen. So what will be it? So you are having O minus Na plus C double bond O double bond O. Now there will be the two cases in which a nucleophile can attack. The first case is directly an oxygen will attack. This will be the first possibility. Or the second possibility is like that this negative charge will conjugate itself and give a charge to carbon, and now this carbon will attack. So which is the most favorable method to deal with it? The first or second? Which is the most appropriate step to deal with? Whether it is first or second? Obviously this is second. Why is it so? Because when the negative charge will come over here, the carbon, the C negative, will be having a way more electron density to attack at the nucleophile, to attack at an electrophile. So this is preferred. So what will be the case? You are having double bond O. There will be a negative charge and it will attack over C double bond O negative. This will be the case, and here the hydrogen is already present. If there will be the case, it means we can say that the aromaticity of the compound is lost. And if the aromaticity of the compound is lost, what will be the case? It will tend to make a compound back again to the aromatic compound. So this will move here, and the negative will take a proton from here, and what will you have? This we can say that this is aromatization. You will be having OH, C double bond O minus. And F, there will be the presence of Na, sodium salt of salicylic acid. And now you are reacting with water, you will be having C double bond O, OH and OH. This will be the final product of this reaction. This is simply a salicylic acid. Very, very important. A very, very important part. Which part of the reaction we have to discuss it again, Sukanya? Okay, again, it means this, there will be the simple. There will be the two pathways. The first pathway in which the negative charge of the oxygen will attack, and in the second pathway, the carbon will attack. So what will be the case? The carbon is having the more nucleophilicity as compared to oxygen, so the carbon will attack at the electrophilic carbon and having the formation of this as an intermediate. And now we can clearly see that the aromaticity of the compound is lost. The aromaticity of the compound is lost. So in order to attain the aromaticity back, what will it can? It can again aromatize itself via, we can say that, aromatization. And if the aromatization occurs, this will be the case. And now you will be having the O negative Na positive, it will be Na positive, and it will and when we are work up again, it means the addition of water, you will be having a salicylic acid. It means the negative charge will oxygen will take in proton from it and we will be getting the product. Is it clear? So this is the Kolbe electrolysis, we can say that Kolbe reaction of phenol. This is not an electrolysis, this is a Kolbe reaction of phenol. Is it clear? Is it clear? Okay, that's impressive. So the major product obtained from the Kolbe reaction of phenol is obviously this will be the NOT, because this is having CHO, this is salicylaldehyde, and this is obviously will not be the case. We have no carboxylic acid, this will also be ruled out, this is also ruled out, and this will be the product. Is it clear? Okay. Okay, this is the product of this question. Okay, moving to the next concept, we are having a question number 79. We have a question number 79. This is a very important reaction while we're dealing with the amines part. And in amines part specifically, this question is regarding a diazonium. We can say that we are having a diazonium salt and we have to prepare a dye. The clothes you have weared has some kind of colors in it. Obviously it has colored, let us say it has a blue color of shirt over there. It means the blue color is not something else, it's just a dye. And now we will be discussing the formation or preparation of dyes. Okay, let us discuss some reactions of dyes preparation using the diazonium chloride. So we are having this diazonium chloride. It's N, so it should be positive, and Cl negative will be here. So this is the benzene diazonium chloride. You are reacting with aniline. You are reacting with aniline. If you are reacting with aniline, it means this nitrogen is having a lone pairs, will conjugate its lone pair over here. This will here, this will here, and the negative charge will form at the para position. And now this negative charge will attack over this position, and this bond will shift over here. Is this approach clear? Okay. And you will be getting, let us say, you are having a benzene which is intact. Nitrogen, if this bond will comes to the N positive, you will be having a neutral nitrogen. That means the double bond is still here. Now nitrogen is already present here, and now this carbon is reacting. If this carbon is reacting, it means there will be the case like this. There will be the double bond over here, and now this double bond will comes over here, and double bond NH2 positive will be the case. Double bond NH2 positive will be the case, and we can clearly say that. What can we say? The aromaticity of compound is again lost. The aromaticity of compound is lost. So in order to attain it back, the hydrogen from that position will migrate its here, will here, and now it will be here, and now you will be having what? A product called this. And the color of this compound, or we can say that the color of this dye is yellow. The color of this compound, or we can say that this dye is yellow in color. Is it clear? Okay, we are having the color of this compound is yellow. And always remember, you are taking an acidic medium here. So let me discuss some more question in the same approach. Let us say you are having again this, and in spite of this, you are reacting with phenol. You are reacting with phenol. So what will be the color of the product formed? If you are replacing the aniline with phenol and you are reacting with the benzene diazoxide chloride, so what will be the color of the dye formed? Can anyone in the class will give me the answer of this? You will be getting a dye of orange in color. Perfect. Shetty has given a perfect answer that the dye formed is orange in color. That's absolutely correct. You will be getting an orange dye. And the medium of this reaction is basic. Is this clear? It means we can clearly say that on reaction of benzene diazonium chloride with aniline, you will be having which kind of color? You will be having yellow color. And if benzene diazonium chloride is reacting with phenol, you will be having orange color dye. Absolutely correct. So this is the major crux of this concept. And always remember, this will be asked, or this has been clearly asked in your previous exams. Okay. Let us move to the next question we have here. Okay, this is simply a chemical property of phenol. You are having a bromine water, you are reacting with phenol, what will you get? Okay, let us discuss some more criteria to deal with. Let us say you are having a phenol and you are reacting with bromine water. This will be the A. And if you are reacting the phenol with bromine in CS2 medium, so the product is B. So my question from you guys is whether A and B are same or different. The product formed, A and B, are either same or different. Obviously they are different. It means we can say that a phenol can decolorize bromine water. The color of bromine water is orangish kind of. So the phenol on reaction with bromine, you will be having OH, it's Br, and Br. This is the product formed on reaction of phenol with this. Obviously, yes, absolutely correct. You are having the formation of product is this on reaction with bromine water. And if you are reacting with bromine in the presence of CS2, you will be getting a mono-substituted product. We can say that Br. This is the major product. Is this clear? Yes, Sophie, this is absolutely correct. It will give an ortho and para products, but independently. Or we can say that the mono substitution will be occurs. This is absolutely correct. This is the mono substituted. This can be the case, and the other case will be the at the ortho position, and the para will be meso. Absolutely correct. So, on moving to the next part, or next concept of this question is this. Now, you will be having a complete scheme of this reaction. Now, you are reacting with aniline with acyl chloride. You are reacting aniline with acyl chloride. The sodium pi, this is the case. Let me discuss it again. If you are having this, let us say you are having this. If the aniline is reacting, it means you are having a yellow product. So, at the yellow, it means the product is acidic. The medium you have to take is acidic in nature. This is simply mentioned over here. But in case of phenol, you will be having to take a basic medium. Okay, now we are having this kind of question. Let us give me an idea to you. So can anyone give me that explanation that what is the difference between acylation and acetylation? What is the distinction in between them? So what is the difference between acylation and acetylation? What is the difference? Then we will move forward. Okay, very good. You are giving an absolutely correct answer for the question. But the main question is now here. Obviously not. Hilal, this is the main difference between them. We can say that acetylation is a type of acylation. Absolutely correct, Faina. if you are having an acetyl group, if you are having an acetyl, which is acetyl? You are having CH3, C double bond O, Cl. Let us say you are taking this. This is acetyl group and you are reacting with something called R, C double bond O, Cl. This is acyl group. We can say that acetylation, if R is CH3, we can clearly say that then acylation is acetylation, only if the R group is CH3. Is it clear? Very good, absolutely correct. So moving back to the question, it means you are reacting the aniline with acyl chloride. So what will you get? Moving stepwise, it means you are reacting aniline with acyl chloride. You are having this. What will you get? It means the nitrogen of this will attack to this position and you are having. This is simply we called a masking of nitrogen. This is NH, C double bond O, R. Okay, and after this, you will be having A. And on reaction of A with nitric acid, we can say that on reaction of A with nitric acid, you will be getting on reaction with HNO3 in the presence of H2SO4. On reaction of this with, so what will be the case? This will generate an electrophile. We can say that NO positive will be formed. So we have an electrophilic center here. Now we have a nucleophilic center here. So which is more, ortho product, para or major? Which will be the major? This is electron donating group. If it is donating group via plus M, so it can be a ortho or para directing. And we are already sure that if there is a presence of nitrogen, it means it will having a minus I tendency. So the para position is more favorable for electrophilic substitution reaction. So we can say that you will get a product called, here we have NO2, here NH, C double bond O, R. This will be the case, or we can say that this is B. Is this clear, guys? Obviously, para is the major product due to less minus I and plus M of nitrogen. Very good. This is para nitroaniline. Perfectly right. On reacting B with OH minus, it means if you are reacting this with OH minus, it means you are reacting the base with this. You can say that there is a demasking here. If this react here, you will be getting, or we can say that if the reaction NH, C double bond O, C, or we can say that here it's already R group, it's general, here NO2, you are reacting with base, the negative charge will attack over here, this will move again, this is NH, CO minus, this is R already present, this is OH, so this negative charge will come over again and this will back to this and the bond will be cleaved. You will be getting NH2 as a final product. Or we can say that the nitro is already present here. There is a presence of nitro group, there will be the presence of nitro group. This is para nitroaniline. This is the final product we are getting. So let us say you are having this reaction, you will be getting a para-nitroaniline, and the option 2 must be the correct answer. Is this clear to you all? Very good. So these are the questions which were asked in your test regarding the chapters alcohol phenols, ethers as aldehyde, ketones, carboxylic acid, as well as amines. Now it's up to you guys. Do you guys have any kind of confusion or doubts? I be here, you can discuss it. Yes, Hilal, what kind of confusion do you have? No, electrophile is NO2 positive. Yes, what kind of question you have? What kind of confusion? No, the electrophile is NO2 positive. But how do you get it? It's simply HNO3 on reacting with H2SO4. You will be release a water molecule and you will be getting NO2 positive. So I have heard with the sulfuric acid, it will give orthonitrophenol. No, it can't be the case. Because HNO3 will evolve when NO2 positive in the presence of sulfuric acid itself. It will yield a para product. No, it can't be the case. And if you are reacting individually the NH2 with sulfuric acid, then it will be the case. But there will be no HNO group. It means you are reacting with sulfuric acid means sulfonation will be occurs, not the nitration. And here we are dealing with nitration. Is it clear? Okay. Any more doubts? Very now, so difference between phthalimide and phthalimide. This is a very interesting question. I have discussed everything in Gabriel phthalimide in the previous lecture. So go watch that lecture and you will be getting a crystal clear difference between phthalimide and phthalimide. In Gabriel phthalimide, you will be getting a phthalimide, not a phthalimide. In phthalimide, there will be two NH2 groups. Go check and see the previous lecture, and after this you will be having any kind of difficulties, do write in the comment section. Okay, we will be clear this soon in the next class. Is it clear? Okay guys, thank you so much for joining this class. We will be meeting in the next class with the same energy